Hello student, the next reaction is Curtius rearrangement. Let me first discuss the principal part. So it is a thermal or photochemical rearrangement of that means we can utilize heat or photo irradiation. So it's a thermal or photochemical rearrangement of acid azide. So your starting material is acid azide in the presence of or in medium of non-aqueous solvent. Non-aqueous solvents, for example, we can say that chloroform, benzene or ether, right? So this is non-aqueous solvent. Non-aqueous means water का part नहीं होना चाहिए. So non-aqueous solvent to an isocyanate. So your intermediate product, we cannot say the intermediate, but its intermediate product is isocyanate, is known as Curtius rearrangement, right? So this reaction is not stop over here. Now this isocyanates on reaction with, or we can say that on hydrolysis, gives primary amine. So here also your final product is primary amine. But the important thing is that with loss of one carbon atom, so we can say that here one carbon atom is less than your reactant molecule. So your reactant is azide, your final product is primary amine, intermediate product is isocyanate, and the important thing is here one carbon atom is less than your reactant. Okay, if we discuss the reaction part, so in reaction acyl azide, RCO, azide means N3, acyl azide, this part is acyl part, RCO, right? For example, Ca3COCl is known as acetyl chloride. So this is acetyl. This is, if we write down this general name, then it is known as acyl. So acyl azide on thermal or photochemical reaction, first it is converted to R and double bond C double bond O, which is known as isocyanate. This isocyanate on hydrolysis or addition of water, it converted to primary amine only, and the side product is carbon dioxide gas, right? So your intermediate product is isocyanate, final product is primary amine. Clear? So the important question is that how to prepare the acyl azide. So let me first discuss the preparation of acyl azide. So for the preparation of acyl azide, we have to use any carboxylic acid. So this carboxylic acid on react with the SOCl2, thionyl chloride. Now as we know that the thionyl chloride replace the OH by Cl. Group. So first it is converted to acyl chloride, which is on react with the NaN3, sodium azide. So here Cl is replaced by the N3 and the side product is NaCl. Right? So it is converted to RCON3 azide group. Clear? If we zoom out this step, then it is R, C double bond O, N, and triple bond N. So this part is positive part. This nitrogen, middle nitrogen is positively charged, and this is the negatively charged. But we generally write like this, N3. Clear? If we move towards the mechanism part, So our starting material is azide, right? So R C double bond O N N triple bond N. So now as we know that this is the positive charge and this is the negative charge. So this molecule can be stabilized if we remove this nitrogen by this bonding pair of electron. We can stabilize this species by removal of this N2 as a stable molecule by withdrawing this bonding pair of electron. This can be possible if this R group transfer from carbonyl carbon to nitrogen. That means here anionic shift. This R group transfer from this carbon to nitrogen with their bonding pair of electron, and that we generally called anionic shift, right? So this part transfer to here, nitrogen is a stable molecule, remove from the molecule as a N2. Now these are connect with the N. Okay, nitrogen carry negative charge na, so it is participate in the bonding. So R N double bond C double bond O, and this part is our isocyanate part, right? Now addition of simply water molecule. So this bond break, one side H, one side OH. So R, so here NH, here C double bond O, and this carbon attached with the OH part, right? And this species is known as carbamic acid. Carbamic acid. Okay, now as we know that if during the mechanism some simple molecule can be released, then always do that, right? So this bond transfer to here, this bond transfer to nitrogen. That means nitrogen now negatively charged. Here carbon oxygen double bond as well as carbon oxygen double bond. So here removal of CO2 is a stable molecule. This hydrogen transfer to this nitrogen because this nitrogen is now negatively charged. So final product is primary amine. Clear? So the mechanism is quite simple, and the intermediate is carbamic acid. Clear? So this is simply example of hydrolysis. The important part is isocyanate, which on take with the water molecule, carbamic acid as an intermediate. Again removal of CO2 molecule as a simple molecule, and the final product is primary amine. So here we can see that our starting material carry one carbon. If we do not consider the R, then it is one carbon containing. Here this carbon is removed as a CO2 molecule. So one carbon atom is less than the starting material. Let me move towards the application part. So here CH3, CH2, C double bond O, Cl. Suppose our starting material is acyl chloride. So as we know that we require azide as a reactant for this reaction. So first it is react with the azide, and this is converted to azide part, here N3. Now we simply heat it. So first case is heat, second case is the hydrolysis. So final product is CH3, CH2, NH2. One carbon atom is less, here 3 carbon atom, here 2 carbon atom. These carbons removed from the molecule as a CO2 molecule. Second application. Suppose the starting material is like this, CH3, C double bond O, and 3, and first it is heating, second one it react with the alcohol, any alcohol part. So in last step here we add the hydrogen and OH. So instead of that, here hydrogen is an RO part, because as we discussed that in case of the any alcohol, this part is negative, hydrogen is positive. So here instead of amine, the final product is like this, right? Here NH2, this is okay, but this RO part is attached with the ester group. So instead of going to hydrolysis part, this product is not possible, and we got this type of molecule. Here NH, C double bond O, O, R, right? Because here addition of hydrogen and addition of OR in isocyanate. Our intermediate is like that, CH3 and double bond C, double bond O. So here hydrolysis, one side hydrogen, another side OR group. So here ester. So we cannot remove the carbon dioxide molecule from here. So this is our final product. Clear? So that's it in the Curtius rearrangement. Thank you.